Ladies and gentlemen, this is Cloud and Clear. I'm Miles Ward. I'm CTO here at SADA, and this is our little way of walking through the fun part of cloud. And I have one of the most fun people. He has maybe one of the better jobs in GCP with me here today. Rob Martin, maybe give an introduction to everybody.
Hey, thanks, Miles. Glad to be here. I'm Rob Martin. I'm the chief architect for gaming at Google Cloud, and I spend my days scaling up gigantic global video games on cloud infrastructure. So it's a lot of fun.
See what I told you? I told you he had the best job. I have been playing video games since before I could speak. And the fact that we're working so hard on building some of these systems so big on the superpowers of GCP is really, I think, incredible piece of work to be doing. So thank you for taking some time with the audience. For folks in the background, I've worked together with Rob on a bunch of projects, so this is kind of like a friendly get back together. I appreciate him blessing us with his presence. Give people the big intro, right? If you're doing games now, like how'd you get there? Why are you doing this for a living? Why does this seem fun?
Yeah, so it's a bit of a circuitous path, but it's a fun one. Before I was working at Google, I worked in a bunch of different industries, but most recently, prior to Google, I was actually working at a bank, and I was moving them to cloud. This was back in late 2017, and Google was looking for people who understood the enterprise and understood cloud. And there weren't a whole lot of us around back then that kind of knew banking and cloud and all that stuff together. So ended up at Google as a customer engineer and worked a few different industries. And then one day I got dropped onto a team that was working on a really, really, really big game. Yeah, you might be able to guess the game. I can't name it.
You can collect them all, right?
Yeah, you can collect them all, but it's one of the really big ones. And those big games are super hard to run on cloud infrastructure. Very demanding, very specific performance requirements. And clouds weren't really built to run those kinds of workloads. And so I just found that fascinating. You know, at the heart of it, it's really an HPC challenge.
Sure.
So we got that game up and running, and it was sort of the first of its kind on our cloud. And then Google just wanted to do that again and again and again. Ran a global gaming team for a while, and now have kind of scaled up to a team of coming up on 20 people that do nothing but work with the world's top publishers to get any kind of game they want to run, running well and at scale in the cloud.
Awesome. So maybe unpack a little bit, right? Like I'm thinking about running a game like I blow on the cartridge and I shove it in the little slot and then...
Yeah, well, it can mean lots of different things. I mean, broadly speaking, you have two types of games, right? You have games that run on your phone. We call those mobile games. And then there are games that run on anything else, a console or a PC or even streaming these days. Mm-hmm. And those are, we call those in the industry, we call those AAA games. So a mobile game might be like a Candy Crush. A AAA game might be like a Call of Duty. Sure. And those two types of games need pretty different stuff. A Candy Crush type game on the back end looks a lot like any kind of big microservices workload. As you're crushing the candy, there's a call that's being made to, an API and kind of keeping track loosely of what's going on. But, other than that, it's kind of like a big microservices workload. It's just really, really big is kind of what sets games apart on the mobile side. On the AAA side, you've got a lot of purpose-built infrastructure that's very, very specific to games, especially when they're multiplayer games. If you're playing a game like a battle royale where you're playing with lots of other players, that's where you got a lot of this very specialized infrastructure that's required to run those kind of games.
I've spent a bunch of cycles, helping people get these kinds of infrastructure stood up. And, on the face of it, you were right to draw the kind of parallel to HPC, right? Like, it's just computers, turn on a bunch of them. Can you give it any more about like what makes the setup for game systems hard? Is it the software that they have that doesn't expect cloud, or is it storage stuff that's no fun, or what's been hard?
Yeah, I'll give you kind of two examples. A AAA game, a battle royale, right? You have to find 100 people to play that game with. And turns out that you have to have 100 people that match each other in a lot of ways. So ideally, you want people that have pretty similar skill levels so that, you're not a newbie in there with like a bunch of veterans and you just get wiped out immediately. But also, just for the gameplay experience, you need to have pretty similar network latency. So that means that you need to be in the same geographic area, and your network path needs to look pretty similar to the other players. And so you have all these different factors that you have to take into account when you find those 100 people. And that's a process that's very specific to gaming called matchmaking. And so that's something that's really, really different than, enterprise applications where you don't really have that kind of concept.
Right. Can you imagine, like, I only want to email other people that are as good at email as I am, right? Like,
yeah, exactly. That would just be kind of weird, But in games, it's like a very necessary component. Another example I can give you is the match itself. So let's say you find those 100 people and now you want to play a game with them. There's a piece of infrastructure called a game server that's running in the cloud that you all actually connect to. And most people don't really think about this because they think of the Xbox that's in their living room as doing all the work. But really, that's just doing the graphics and sound for that one player. And everything else for that multiplayer match is happening up in the cloud on this game server. And, that game server is really running a simulation in real time of that world. And it's running that simulation and sort of transmitting it out to all the players. And that's, what really drives like the other players moving on the screen and who finds what and, who's getting hit and who's surviving. Like that's all calculated on the server side and it's happening in real time. So you can almost think of this game server as like a movie projector that's like creating frames of this simulated world in real time. And just like a movie projector, like if it started slowing down and speeding up due to like virtualization and stuff, the game just gets really weird. So that drives a lot of very specific hardware requirements that are really, really hard to do in a multi-tenant cloud environment.
Yeah, I had always spent time focused on the mobile side of games because those I think were some of the very first ones that came to public clouds of any kind. And it was Joe Hawley when we were working together, the folks at Respawn as they were getting ready to launch the precursor to Apex Legends. First, it was Titanfall 2. And they're explaining, yeah, like if you have an Xbox, the cloud has to have an Xbox too. Right? I'm like, oh no, like there are a lot of Xboxes out there playing. Like that multiplication problem starts to get pretty gnarly pretty fast. And yay, thankfully, it doesn't have to run all of the graphics that your in thing does, but that's not much of a benefit, right? The simulation itself is pretty computationally expensive.
It's pretty gnarly. Yeah. People don't think about how much computation is happening in the cloud for a game like Call of Duty. And some of these, if you take the fleet, the game servers for all the players around the whole world, these can be hundreds of thousands of cores running all at once for just one game, one big game.
I've seen a bunch of demonstrations now as folks are kind of crossing over into cloud where there was only so many and a certain level of sophistication for the kind of hardware devices they would deploy locally. But cloud, you got all sorts of toys. And so, machines with a terabyte of memory and machines with 224 cores and right, like these way bigger environments than would sort of financially make sense if you were just going to stand up a little chunk of co-location to run your one little game. And so I think it's going to be fun to watch kind of what new game capabilities come out, what features are possible for users as you have these kinds of new superpowers from cloud.
Oh, for sure. The traditional world, you just had these basic servers that were running in colos. And, one of the things that's also kind of interesting about these game servers is really one of the early use cases for edge compute. A mobile game like a Candy Crush, for example, could run out of one region, and serve the whole world because the latency requirements aren't that high on the mobile side. But when you're running a console game, you've got to be exchanging packets with the cloud in like 30 milliseconds, which means that you've got those game servers in data centers all around the world. And so it's really was one of the first sort of uses of what you might think of as edge compute. And so some of these game developers now are starting to think, wow, what happens if we can get those game servers out even closer to the players, out in the 5G edge or other places like that?
There's the hardware part of it, sort of lovely sitting in the context of Google's however many $billion a year of investment in physical equipment. But there's also the software part of it, right? I mean, we were working very early on in trying to get companies to be able to think about scaling applications in a similar way to the way Google does it internally for itself using containers. And the advent of Kubernetes for a bunch of these workloads just radically simplifying the scale up and scale down and deployment and registration of new versions of the software are like, I know that's been a big shift. And there are a couple of other open source pieces. You want to, I mean, like, seems like there's kind of like a stable of great stuff that's being built at this point.
Yeah, there really is. So, when I talk about the matchmakers and the game servers, traditionally these game developers just had to take like bare metal servers or VMs and write a whole ton of software to do that stuff. And it was really, really hard. And, the really leading developers got really, really good at it. And everybody else kind of struggled because it's actually a very hard problem.
At the beginning, it was like, you can't hire Carmack, and he's the only guy who can make the sort of visual engine work right. And then like once they got the visual engine part worked out, now it's networking stack. And once they got the networking stack figured out, like you just keep moving up the stack of problems.
Yeah, and it's just they're really hard problems. And so it was really hard to make these big like battle royale games because all kinds of gnarly scaling problems that you have to deal with all around the world and a dozen different data centers. So we think that Kubernetes and containers obviously solve a whole big portion of that problem for you. And maybe there's just a little bit more that you need to add on. So it really helps democratize this idea of writing like a globally scalable matchmaker when you can use microservices, or scaling game servers in 12 different data centers when you got Kubernetes to help you scale up and scale down and do health checks and things like that. We really, at Google, we think that, containers are the future for gaming, just like they are for many other things. But, the industry takes a little while to sort of adopt that new technology. And that's one of the areas where we're really leaning in and looking to partners like SADA to help lean in. And
we've got a bunch of customers that we've worked on together that have done some great deployments, and they've been using not only Kubernetes as a building block, Agones is another super powerful tool, the matchmaker that Joe pulled together. There's a bunch of other pieces there. You're talking about superpowers, right? Like rather than adding new pieces, I was super excited about deleting some pieces, right? Stadia as an offer from Google, it's like, you can have a console with no console, right? Like what a huge shift in the way to approach delivery of games for folks. How does Google Cloud and Stadia, and how does that all go together?
Yeah, that's a really great question. I mean, Stadia, I think, has been an eye-opener for the industry because I think a lot of people were skeptical that the tech could work. Like, can you really move a console up into the cloud and have it work? Gamers have high expectations for frame rates and input latency and things that like normal people don't think about. But, I've got Stadia in my house and it runs like amazingly well. Like we play Red Dead Redemption on it. We play Mortal Kombat 11 on it. And like, the tech works. And so I think for the industry now, especially with COVID, people are thinking a lot more about how to stream content. And, a lot of studios are thinking about the new types of gamers they might be able to engage with if buying a big expensive console wasn't like the price of entry. And we've got enterprises now that are, thinking about leveraging game engine technology. And obviously, you're not going to have an Xbox in the home of someone that's looking to buy cabinets, but you do have a web browser. And if you can stream interactively to that web browser, now you're starting to open up this 3D technology to use cases beyond gaming.
I was absolutely in the skeptical club. I ran a all-girls sorority Quake deathmatch tournament in college, right? And by gum, latency matters. And so they had a game, it was like one of the very first free games in Stadia called Thumper, where it's literally like a timing game. Like you've got to push the button at just the right millisecond to make sure that you like don't screw up the sort of music that's playing and the lights that are going. And I'm like, oh man, this is like the canonical example of a kind of game that will not work right in a thing like this if the latency is working. And it's hysterical, like it completely reliable, totally smooth. I have good internet, but I don't have crazy internet. And I'm doing it like just off my little Chrome box bit, right? Like tiny little thing that's running all of it. All my little nephews, they want to play games. GPU is kind of hard to come by. Either I, go to eBay and part with $3,000 on last year's GPU, or send them the $100 Stadia controller, right? Like, I don't know, that might work a little better. So it's been pretty great to see the cloud providers and their ability to buy at such incredible scale help in these kinds of complicated access issues.
Yeah, for sure. I mean, if you rewind, a year or two ago, we weren't talking about GPUs at all in gaming. Like it was all game servers and APIs and matchmaking and data analytics and that sort of thing. And, now that Stadia has sort of opened people's eyes to the possibility of streaming, we're talking about streaming all the time, every day. And not only on the content delivery side, which is, Stadia is delivering the game experience to you, but also on the content creation side with things like pushing the game studio into the cloud. I was just chatting with, a studio the other day, and they showed me a whole room full of developer workstations that were waiting to be built, like 25 machines. And they had all the parts, but no GPUs for any of them. No GPUs. And so they got 25 developers that are sitting on their hands, waiting for a computer that they can build content with. And I think that's another great example of a use case that, cloud GPUs can help unlock.
I've been really excited about the performance that we've been able to help customers that we're working on in joint. I mean, the Fungi folks have gone super fast. The High Five Games folks were able to get up and going quickly. If other folks are trying to learn more, want to get an idea of how to get in contact with Googlers who are fired up about game serving, are there other kind of environments where they can go learn about this stuff?
First of all, we've got an email address that they can reach out to our team at gaming-solutions@google.com. So we are always happy to help get people pointed in the right direction. We're also going to be presenting an entire day's worth of content at Game Developers Conference this year. So I'll be doing a keynote, and folks on my team will be talking about cool things like Spanner and Agones and Virtual Studio. And so that's a great opportunity to get, a deeper dive into each one of these technologies.
Spanner's hot magic. I worked together on the Dragon Ball Z project, right, where you're literally shooting fireballs at each other from Europe all the way to Japan real time, and it just works, and there aren't any problems. Being able to have Spanner sit in the middle of these things to create that global, transactionally consistent environment, it's just such a superpower. And I was just spent a bunch of time with Dipanjan, who's one of the product managers for folks in charge of a bunch of these systems. The roadmap for Spanner is fire, man. They are really going to go after it. I'm excited about kind of the next generation of games being able to take advantage of some of the super new tools that are coming.
Yeah, Spanner is really a bit of a miracle. I mean, atomic clocks and all kinds of wizardry that goes into making it work. But, in gaming, a lot of times what happens is developers take these very pragmatic solutions to really hard problems. So, you need a big, gigantic database for one of these games that I've been talking about. That can't all fit into one copy of MySQL. So let's make 500 copies of MySQL. And then another copy of MySQL to keep track of where all the data is. And let's just try and run all that stuff for a game. And, when we get a lot more players, we got to add more servers. And when we get a lot fewer players, we got to figure out how to put all that data back together. And it's just really painful. Or you could just use Spanner. So we're seeing a lot of adoption for Spanner in gaming these days also.
I was working at Amazon, and I met Eric Schmidt. And I said, I don't know why I would go work at Google on cloud. I think Amazon's doing really well. He said, you should read the Spanner white paper. I said, okay. I read the Spanner white paper, and I changed jobs.
This is the kind of stuff that gets folks like you and me excited about working on Google Tech. Spanner is just one of many cool things that we can deploy.
Oh, yeah. Hardware for ML that's a zillion times faster, storage that actually works right, identity and access management that's globally transactionally consistent. You don't actually have to fight with this stuff. There's a bunch of big pieces. Well, look, Rob, I super appreciate you taking the time. I think everybody should go to that GDC conference. I will certainly go and watch your talk at GDC. Any last bits you want to leave with folks, stuff that they should check out, places we can learn more?
Yeah, I think I'd love for folks to check out our content at GDC. Check out Agones. We just launched a new solution with 2K Games called Open Saves. I'd encourage folks in the industry, check that out. Think about what you can do with our open source solutions for game save data. And hit us up at our email address and let us know how we can help. We love working together with game devs to scale up really, really big games in the cloud.
Big games! All right, Rob, thank you so much. And everybody, really appreciate you taking the time. This has been Cloud and Clear. Have a great day.
Thanks, Miles. Appreciate the invite.
Cheers.
Thank you for listening to Cloud and Clear. Check the show notes for links to this week's topics. And don't forget to connect with us on Twitter at Cloud and Clear and our website, SADA.com. Be sure to rate and review the show on your favorite podcast app.